All right. So our first quadrilateral is asking us to determine so for all of these examples that we're going to do, numbers 1, 2, and 3, we're going to use the vertices and try to prove that it's a parallelogram, then a rectangle, then a rhombus, and a square. And we have to explain our reasoning, meaning we have to justify every single step. So the first thing that we're going to do is graph the shape. So first, we're going to graph the points and connect them with segments. That's the first thing that we're going to do because this is a quadrilateral, okay? So I'm going to graph my ordered pairs. And this graph is horrible for me to read. I have to make these lines really dark so I can tell which one is my x-axis and my y on this grid. Okay, so our first ordered pair, and we're going to label them as we plot them. So E is the ordered pair 2, 1. This is point E right here. F is the ordered pair 3, 4. G is the ordered pair 7, 2. And H is the ordered pair 6, -1. Okay. So once you plot your ordered pairs, you're going to connect in the same order that you plotted them, and they're usually in ABC order. So connect E, F, G, H back to E. So what do you think about this quadrilateral? What do you think about this quadrilateral? You think it's a rectangle? I think it's a parallelogram, and we can't prove it's a rectangle until we prove it's a parallelogram. So let's do that first. So second, we're going to show that it's a parallelogram. And what method are we going to use? What method are we going to use? What did we highlight in our methods? How do we prove? Say again. Yeah, what is the first method? Because I want to write it out here. Show the diagonals bisect. Yeah. So I'm going to write showing diagonals bisect each other, and in parentheses, I'm just writing midpoints. We're going to use the midpoint formula. So let's talk about the diagonals. I have to draw the diagonals so I can see what they are. Let's see, I have diagonal EG and diagonal FH. Braden, are you not going to take notes today? You just opting to not do notes? Okay, pick up your pencil. So diagonal EG. Let's find the midpoint of diagonal EG. So I'm just going to add the x coordinates of E and G. So 2 plus 7 divided by 2. And I'm going to add the y coordinates of E and G. 1 plus 2 divided by 2. Well, 2 plus 7 is 9. And 1 plus 2 is 3. And I'm just going to leave it just like that. I'm just going to leave it as 2 simplified fractions. So the midpoint of EG is the coordinate 9/2, 3/2. Now we need to find the midpoint of FH. Okay. So I'm going to add the x's of F and H. That's 3 plus 6. And divide it by 2. And then I'm going to add the y coordinates of F and H. That's 4 and -1. And divide that by 2. Well, 3 plus 6 is 9. That gives me 9/2. And 4 minus 1 is 3. That gives me 3/2. Are the midpoints the same? Yes. So we're going to kind of put a little squiggly bracket here, and we're going to say that EF, can someone grab the door? GH is a parallelogram because midpoints of the diagonal are equal. EFG is a parallelogram because the midpoints of the diagonal are equal. Okay. I know this is a lot. I know it's tedious. We're going nice and slow, right? So we've shown that it's a parallelogram. Next, we need to prove that it's what kind of shape? A rectangle. So third step, we're going to show it's a rectangle. And what method are we going to use? Which one did we highlight? Yeah, we're going to show that the diagonals are congruent. So we're going to show that the diagonals are equal in distance. That's going to be our distance formula. So we have to find the distance of EG and the distance of FH. So that's where we are now, okay? We're finding the distance of EG and the distance of FH. So distance. The distance of EG. Okay. So the square root of, I just need my order of pairs. So 7 minus 2, the quantity squared, plus 2 minus 1, the quantity squared. So what is 7 minus 2? Yes, it is 5 squared. And 2 minus 1 is 1. So what is 5 squared plus 1 squared? Anybody? 5 squared plus 1 squared. Come on, you guys. This is going to take us forever if we don't participate. What is it? It's 26. So I have the square root of 26. So the distance of segment EG is whatever the square root of 26 is. I don't care what that exact measure is. I'm just leaving it just like that. Okay. I'm just going to compare the two. Let's find the distance of FH. Okay. So x sub 2, that's h. 6 minus 3, the quantity squared, plus negative 1 minus 4, the quantity squared. Okay. So what is 6 minus 3? So I have 3 squared plus, what is negative 1 minus 4? Negative 5. Rylan, is that you doing all the participating up there? Thank you for that, sir. So 3 squared plus negative 5 squared, that looks like 9 plus 25. What is 9 plus 25? Is the square root of 26 equal to the square root of 34? No, it is not. So this is not a rectangle. Okay. Does it look like it's a rhombus? Do the side measures look the same? Do all 4 sides look like they have the same measure? No. We're not even going to try and prove that it's a rhombus. And if it's not a rectangle, there's no way that it can be a square, right? And we know it's not a rhombus. So we're done with that. So EFGH is only a what kind of shape? So let's write that. EFGH is a parallelogram. And that's it. All of All of our work that we just did proved that it is just a parallelogram. That is it. Okay. All right. I know. Number 2. Let's go to number 2. What do we do first? Yeah, we're going to have to graph our ordered pairs. Number 2, we're going to have to graph our ordered pairs. So you guys need to make sure you have your calculators open because I'm not doing all the math and neither is Rylan. So let's graph our ordered pairs. Our first ordered pair, D, 1, 3. Graph it and label it. Graph it and label it. Manuel, pick your head up for me. I know you're not sleeping. Just pick it up. E is the ordered pair 7, -3. E, 7, -3. F, the ordered pair 1, -9. So F is way down here. And G is the ordered pair -5, -3. So D, E, F, G, back to D. So that was our first step. Graph. Done. Okay. Now what are we going to do? Prove it's a parallelogram. How are we going to do that? Okay. Good job. So I'm going to write parallelogram. I'm going to put midpoints because that's the method that we're going to use for that. Diagonals bisect. That's my little note. That's what we're proving, okay? So I'm going to write nice and big so everybody can see that. So parallelogram, midpoint, diagonals bisect. So did we draw our diagonals? I don't think I did. Oh my goodness. Let's undo that really fast. Oh. There. Okay. That won't happen twice. Still not lined up right. Okay. So diagonals. Let's draw those really fast. I have diagonal GE and diagonal DF. So I just want you to have a visual of what we're doing there. Okay. Diagonal GE and diagonal DF. So we want to show the midpoints. So I need to find the midpoint of GE and I need to find the midpoint of DF. So I'm going to add the what coordinates together first of G and E. I want to use the midpoint formula. What do I add? Hello, Earth to students. Midpoint. Carter, how do I find the midpoint? So let's add the x coordinates of G and E. -5 plus 7 over 2. The y coordinates of G and E. -3 plus -3 over 2. So -5 plus 7 is 2. So that's 2 over 2. -3 plus 2. -3 plus 3 is -3 over 2. Sorry, -6. I'm so sorry. So what does this reduce to? 2 over 2 and -6 over 2 reduce to what? 1, comma, -3. Do you see that? Let's do let's do GDF. Sorry, I'm out of order compared to you guys. Let's do DF. So D and F, x coordinates, 1 plus 1, it looks like, over 2, y coordinates, 3 plus -9. So 1 plus 1 is 2, and we know that 2 over 2 is 1. What is 3 plus -9? And what's negative 6 divided by 2? So what can you tell me about the diagonals? They're what? They're not equal. What did we just show? They have the same what? They have the same midpoint, which means they bisect each other, which means that DEFG is a parallelogram. Okay, DEFG is a parallelogram. So that's step number 2. So now we have a parallelogram. What are we going to do next? How? Yeah, we're going to use the distance formula, and we're going to show that the diagonals have the same measure. They're equal to each other. Okay. All right. So distance of GE, distance of DF. So distance of GE and the distance of DF. Okay. So ordered pair GE. Let's see. I have negative 5 minus 1 squared. Oh, sorry, that's 7. Minus 7 squared plus negative 3. Minus a negative becomes plus 3 squared. All right. So what's negative 5 minus 7? It's negative 12. So negative 12, the quantity squared. Plus, what is negative 3 plus 3? And I'm not even going to square it. What is negative 12, the quantity squared? It's what? Positive, not 24. What's 12 times 12? And the square root of 144 is 12, correct? Let's find the distance of DF. Okay, so F1 minus 1, the quantity squared, plus negative 9 minus 3, the quantity squared. What is 1 minus 1? 0. What is negative 9 minus 3? Same signs, add and keep. Are the signs the same? Are those signs the same? Negative 9, negative 3, are the signs the same? Yes, we just add those two together. Keep the sign. 9 and 3 is 12, so this is negative 12 squared. What is negative 12 times negative 12? Positive 144. So I have the square root of 144, which I know is 12. So what did we just prove? Yeah, we proved that this is a rectangle because the diagonals are congruent. And that just means that they have the same measure. They're congruent. They have the same measure. Whew, you guys are doing excellent. All right. So step number 3, we showed that it's the diagonals are congruent, which means it's a rectangle. What are we going to try to prove now? Before we prove it's a square, we want to show that it's a rhombus. How are we going to show that it's a rhombus? What do we use for rhombus? Yeah, we're going to show that the diagonals are perpendicular. So we're going to use slope. Diagonal 1 is perpendicular to diagonal 2, meaning that they have the opposite reciprocal slopes. Opposite reciprocal slopes. So we have to find, I'm going to use little m, we have to find the slope of diagonal GE, and we have to find the slope of diagonal DF. All right, how are we doing? We doing okay? Tell me about slope. How do I find slope? What's the slope formula? Excellent job, Gerardo. Y2 minus Y1. So let's see. GE, -3 minus a negative, is a positive. So -3 plus 3 over -5 minus 7. I'll let you guys think about that for a second. Tell me what my slope is. It's 0 over -12, which equals what? Yeah, 0. That means that that's what kind of line? It's horizontal. Good job. That helps my brain process. Horizontal line. Okay. Let's do DF. Let's see. F, y coordinate, -9. D, +3. So -9 minus 3 over 1 minus 1. I'm going to let you think about it. What do you think, Kian? What's -9 minus 3? Same signs, add and keep. God bless you. Are the signs the same? So we add them together. God bless you. -9 and -3 is -12. Kian, what's 1 minus 1? What kind of slope is this? Someone put that in their calculator for me. It's undefined. It's undefined. You can't divide by 0. What kind of line has an undefined slope? A vertical line. And we know from proving with Pythagorean theorem, we know that horizontal and vertical lines are perpendicular to each other, right? That's how we took every line segment and turned it into a right triangle on our grids for Pythagorean theorem. So, have we shown that these are perpendicular to each other? Yeah, this is a rhombus because segment GE is perpendicular to DF. Horizontal and vertical lines are perpendicular to each other. So, can we prove that it's a square? Yeah, so we don't have to do any math. We just have to say DEFG is a square because it is a what? What do we show first? First, we showed that it's a parallelogram. And what else did we show that it was? Then we showed it's a rectangle. And lastly, we showed it's a that was a lot of work. That was a lot of work. Okay. All right. We're going to jump to question number 4 on page 34. We're going to jump to question number 4. So question number 4 just is asking us to locate the fourth point to create that designated or identified quadrilateral. So I want you to look at number 4. It says, hey, I want you to create a parallelogram. So we know that parallelograms have to have the same slope for their opposite sides, right? Their opposite sides have the same slope. So what do you think I could do to count to make sure I knew where to put that ordered pair? Because we're missing a point. We're missing one point. Yeah, what if I counted how much I have to go up and how much I have to go to the right? That's my slope, right? So let's see. To go from this point to this point, I have to go up 1, 2, 3 over 1, 2, 3. So up 3 to the right 3. So what if I went down 3 and to the left 3? Does that have the same slope? It does. What is that point? What is that ordered pair? That's the ordered pair 1, 0. That's the point that we added. Example number 5 wants us to create a rectangle. What ordered pair do we need to add to make a rectangle? Yes, good job. We need to add a point right down here at -4, -8. Okay, now we're going to jump to some triangles. They're much easier. We're going to jump to some triangles. They're much easier. They have fewer points, right? So page 35, let's talk about some triangles. Page 35, we're going to look at some triangles. So this is stuff that you learned in elementary and middle school. So recall that triangles can be classified by their sides and their angles. So what is the name of a triangle that has no congruent sides? Do you guys remember? What's that called? Nope. I'm going to actually change. It's not obtuse. It's called scalene. Scalene. So none of the sides have the same measure. This is a scalene triangle. Scalene. None of the sides have the same measure. If at least two sides are congruent, that's called an isosceles. So if I were to draw a sketch of that, I'm going to mark these sides congruent. That's what it means by draw each triangle with the correct markings. Okay. What about if all three sides are congruent? What's that called? All three sides are the same. Yeah, equilateral. All three sides are the same. Okay. Equilateral triangle. So the next 4 examples have to do with angle measures. So if I have an acute triangle, that's what this is called, an acute triangle. It just means that all 3 of the angles are less than 90 degrees. All 3 of the angles are less than 90 degrees. If I have 3 congruent angles, this is called equiangular, which actually is also equilateral. They're the same. And it just looks like this. This side is congruent to this side, is congruent to this side. If I have one right angle, well, we call that a right triangle. We show that we have a right triangle by putting what on the right angle? Yeah, that little box right here, that 90 degree. And then if we have one obtuse angle, that just means that one angle is greater than 90 degrees. So I'm going to mark this at like 120 degrees, just so you can see that it's greater than 90. So those are pictures of triangles. That'll help you when you graph a triangle. So we're going to do example number 1 and example number 3, and then we'll be done. Example number 1 and example number 3. That perimeter is our tomorrow lesson. So let's go to example number 1. Emmanuel, you with me? Example number 1, use coordinate geometry to classify this triangle as scalene, isosceles, or equilateral. So first thing that we're going to do is what? Graph the coordinates. So -2, -2, that's A. +2, -2, that's B. 0, 5, that's point C. Oh, let me fix that. That is not on 0, 5. That's on -1, 5. 0, 5 right there, C. So what does this look like? Yeah, it looks like an isosceles triangle. So I'm going to write that. It looks isosceles. So I need to prove it. So I need to show that what two sides have the same measure. Yeah, I have to show that AC is equal to BC with the distance formula. It says distance form. Sorry. So let's do that. I'm going to use the distance formula. So the distance of AC. High or low? What's going on with you, bud? Do you need a snack? Distance of BC. I need someone to set up AC. Coming back, you can tell me what the numbers are. What am I putting in there? Someone calculate the distance of AC. Do you have water? No. I watered my plants this morning. It's fresh water, but it's for my palm tree. We'll have to fill it up when we're done. Palm tree's a little dry. Sorry. I'm trying to save it. Trying to rescue a palm tree. Okay, so here we go. Stop. AC. So I'm going to find the distance from A to C. 0 minus a negative is plus 2, the quantity squared. And 5 plus 2, the quantity squared. So 0 plus 2 is just 2. 2 squared is 4. 5 plus 2 is 7. 7 squared is 4 plus 49 is 53. So it's the square root of 53. Let's find the distance from B to C. So 0 minus 2, the quantity squared, plus 5 minus 2. 5 plus 2, the quantity squared. So 0 minus 2, well, that's -2 squared. And -2 squared is +4. 5 plus 2 is 7. And 7 squared is, and so do they have the same measure? Triangle ABC is isosceles. Triangle ABC is isosceles. Okay. We're going to skip number 2. Did everybody get that? We're skipping number 2. And we're going to go to number 3. Number 3 just asks us to prove that this is a right triangle. Prove that UGA is a right triangle. So first we're going to plot our points. -3, +3, U, 1, 7, G, 5, 3, A. When I connect the points, which angle appears to be the right angle? Which one appears to be the right angle? Yeah. It looks like angle G is the right angle. In order to prove it, we have to show that segment UG is perpendicular to segment AG. Okay, we're showing that UG is perpendicular to AG. How do we do that? With slope. So the slope of UG, 7 minus 3 over 1 plus 3. Well, that equals 4 over 4, which is 1. The slope of AG, let's see. So 3 minus 7 over 5 minus 1. So 3 minus 7 is negative 4. 5 minus 1 is positive 4. That equals negative 1. Are the slopes opposite reciprocals of each other? Yes or no? Yeah. So triangle UGA is a right triangle because UG is perpendicular to AG. UG is perpendicular to